Hey, welcome back to the channel. Rutherford FPV and more here in the next video in the series for setting up ArduPilot on our custom 2.5-inch build. In the last video we set up our harmonic notch filter. We did our first step in the autotune. Off screen I did the next two axes. So we're going to take a look at how autotune did. So we go over to the config tab, come over to extended tuning, and you can see that autotune has dialed in the PIDs for each of the three axes. Later in this video, we're going to set up the optical flow sensor and some Lewis scripts, but before we get to that, I want to take a look at some of the logs to see how our filtering and the autotune is doing, and then make any necessary adjustments before we move on. So let's come down to the full parameter list, type ins_log. We're going to come to the BAT options, select pre and post filter, and then we're going to search for log_bit. And we're going to come up to the bit mask, and we're going to make sure IMU is selected and PID is selected. There's also a few other parameters we need to set up so the notch filtering actually works. In the previous video, I only set up a few of them. So let's go to RPM1, and we're going to set this to ESC telemetry. Right parameters, we're going to need to refresh. And then RPM mask, set those for the four motors. Then we're going to go to servo_BLH. The number of poles, we're going to change to 12 for our motors. Then we're going to write parameters, save, and go do a test flight. All right, I'm back from doing my test flight. I've downloaded the log file and I've uploaded it to the ArduPilot filter review tool. Now before we take a look at this, let's take a look at the filter review tool results from our very first flight. Remember, we saw the two peaks here, and then we set up the notch filtering and then used the estimated post filtering to take a look at the filtering results with that harmonic notch filter set up. Comparing that to the latest test flight that I just did, let's scroll down here. And we only see one significant peak here instead of two, so unclear what changed between the two test flights other than the parameters that we set up in ArduPilot for the ESC telemetry and the RPM data to support the notch filtering. But regardless, we have one peak here at about 350 Hertz, and the notch filter was set up at 325 with a bandwidth of 80 Hertz. That's a recommendation of using 1/4 of the frequency if we're using ESC telemetry or RPM based filtering because of the four motors. If we scroll down, we can see the pre-filter, we can see our significant peak here. Post-filter, it's cleaned up pretty well. Now we do still have some noise and some orange down here, and there is definitely some room for improvement, but that's not something that we need to worry about right now. Okay, now let's take a look at the UAV log viewer. So I've already loaded up the same log file, and let's go down and take a look at the oscillations. So RCOU, C1, looks good, C2, 3, and 4. This looks significantly better than the initial test flight where we saw some really significant oscillations. So the logs that we were just looking at were for a gentle hover. I'm going to do another test flight off screen, and then I'm going to come back here. We're going to take a look at the logs, and we're going to see how the PIDs are performing when I give the vehicle some pitch and roll commands. All right, be back in a sec. Okay, I'm back from that test flight and I've downloaded the log. Instead of using UAV log viewer, this time I'm going to show you how to use Mission Planner to review the log. So if we go to the main screen on ArduPilot, you don't even have to be connected. Just scroll all the way over to the Data Flash Logs tab, hit this button, Review a Log, find your log file, open it up. Let's go ahead and maximize this screen, and then along the right side you have your list of parameters. So this looks kind of like UAV log viewer, just on the other side. So let's go pitch, target, and actual. This is the target pitch and actual plotted on the same graph here. This is following our first iteration of autotune. So ideally you just want these lines to be on top of each other. So pretty close. Let's remove these and let's go to the roll, target, and actual. And this looks pretty good. So we're going to run autotune maybe a couple more times just to really dial this in, but we won't do that until later. For now, let's start setting up the optical flow sensor so we can get the Loiter flight mode working. Okay, we're back in Mission Planner. Let's go to the config tab, full parameter list. The MTF-01 optical flow sensor is connected to UART4, so let's go to serial 4_. We're going to do serial 4 protocol is mavlink 1, baud rate is 115, and options 1024. Right parameters. Now, if you remember from the build videos, the MTF-01 that we bought was for PX4. We need to reconfigure this for ArduPilot. Even if yours was purchased for ArduPilot, it's good to just double check that it's configured correctly. So let's go to Google, type in Miko Assistant, click that first link, and this is the software that you're going to use to configure your Miko Air MTF-01. Okay, let's reboot our flight controller. So Data tab, Actions, Reboot. And then let's go back to the full parameter list. Now we need to set the serial pass-through parameters so that we can communicate to Miko Assistant. So we're going to type serial_pass. We're going to set the pass-through on serial 4, and then the timeout to 30 seconds, which should give us enough time to connect to Miko Assistant. We're going to write parameters, disconnect, and then we're going to launch Miko Assistant. So in Miko Assistant, make sure you have COM23 and a baud rate of 115. Hit connect. And now you should see the data showing up for your MTF-01. Come down to the gear icon to configure this. We're going to select the protocol to MAV APM, and we're going to write. Then we can close out, disconnect, and we can close Miko Assistant. Back in Mission Planner, let's reconnect. Then we're going to type in flow_type, and we're going to set the value to 5. We're going to type in RNG-FND1, and we're going to set the value to 10. Write parameters. Now the list of parameters should have updated. So we're going to do range find 1 max. The MTF-01 has a max range of 8 meters, a minimum range of 1 centimeter, and make sure that the orientation is 25 for down. Now let's write parameters, and we're going to reboot our flight controller. Now to make sure that the sensor is working correctly, go to the status tab, scroll over to OPT_QUA, and you should be seeing a value change. So as I move the vehicle on my desk, this value is changing. That's the optical flow sensor data. And then if we scroll over to rangefinder 1, as I move the drone up and down on the desk, this value is changing, so the rangefinder is reading data. We're seeing the serial 4 options pre-arm error from when we configured the serial pass-through. Let's go over and just get rid of this. Serial 4_options, reset that to 0, write parameters. Okay, so we've set up the MTF-01 optical flow sensor to work with ArduPilot. Now we need to set up the parameters so it can actually be used as a flight mode. We're going to type EK3_source1, and we have position XY. We're going to go to the drop down and select none. Position Z, use the barometer. Velocity XY, we're going to use optical flow. Velocity Z, none, and yaw, none. Write parameters. Now, anytime we switch from stabilize or altitude hold mode into loiter mode, ArduPilot is going to be looking for these parameters, the EK3 source 1, to determine which sensors to use for its position holding. ArduPilot requires a position origin in order for the loiter mode to work, but without a GPS attached, the origin's never set. So let's take a look at the error that ArduPilot is going to give us. Go over to the data tab. Okay, so I'm in stabilize mode, as you can see here in the heads-up display, switching to altitude hold mode, and now switching to loiter. You can see flashing in there, pre-arm error, we need a position estimate. So with that pre-arm error, we're never going to be able to take off in loiter mode, and if we are in flight trying to switch to loiter mode, it's not going to work. So to get around this, we can use a Lua script to set the origin manually. If we go over to the ArduPilot GitHub page, there is a Lua script already written that sets the origin manually for us. So we just drop this into our Lua scripting folder in Mission Planner, and this will run on boot up, and then we'll be able to use the loiter mode. So let's go ahead and download this, come back over to Mission Planner. We're going to go to the config tab, MAV FTP, click on the root folder and expand it, APM, expand it, and then scripts. Then find that Lua file that you just downloaded, and then you can drag it into Mission Planner. There's the Lua file. The next time the flight controller boots up, this Lua script is going to load, set the dummy origin, and we're going to be able to switch to loiter mode. Before we test out loiter in the field, there's a few other parameters that I need to set. So let's go to the full parameter list, type in compass_use. Since we don't have an onboard compass, we're going to disable each of these. EK3 magcal, since we don't have it, we're going to set to never. And then we're going to set compass enable also to 0. And then we're going to go over to GPS1. GPS1 type is none, and GPS use disabled, and then write parameters. Okay, let's go test it out in the field. Well, as luck would have it, it's bad weather outside, so I'm going to do the test flight indoors. What I'm doing here is I'm taking off in stabilize mode, and then I'm going to switch over into loiter mode. Right now I'm kind of just struggling with the barometer, so I'm in loiter mode now. You can see that the barometer is struggling a little bit with the ground effect, but it is coming into a stable hover with the position hold using the optical flow sensor. So there's a little bit of drift because I'm getting a lot of wind off of the walls behind me and in front of me, but you can see that it's doing a pretty good job just keeping its position in the XY and the barometer trying to hold the Z. So we're gonna need to tune the barometer a little bit. Here you can see the position holding with the optical flow. So just giving it some gentle taps from the back, from the top, and from the sides, it's able to hold its position pretty well. So I'd say for just a first flight with the optical flow sensor, this is doing pretty good. We're going to fine tune these later in some coming videos, and hope you've enjoyed. Thanks for watching.